welcome back. We're going to be looking at example in dimension. So we have this. We want to learn how to apply dimension in solving out the formulas or in deriving the formulas of a given physical quantity in physics. Is that clear? So let's take for an instance when we have an experiment. In this example, we have an experiment where we have a string fixed at both ends. This is a string and it's big at both ends, A and B. It is plucked. When you pluck this string, it will do what? Vibrate. Whenever it vibrates, the velocity of the wave of the vibration depends on the what? Tension, F, length, L of the string, and the what? Mass of the string. Now by implication, the velocity produced is proportional. The velocity is proportional to what? Tension, length, and what? Mass. So if you remove these proportionalities and you introduce a constant known as k, so that you now put equal to. But now you don't know the degree to which the tension, the length, and the what? Mass affects the velocity, which is what we are going to use what? Dimension to find, so that we can establish the actual what? Formula. So that we can establish what? The actual formula. So from the statement, let's assume that we have, assuming V to be equal to constant of proportionality K, tension, length, mass, isn't it? Yes. But we don't know the degree, so we have A, we put A, we put B, and we put what? C. So let's call this equation 1. Is it? Okay. So we want to find the actual quantity. But we know that velocity is equal to what? What is velocity? LT minus 1. Is that not the dimension of velocity? Yes. The dimension of velocity is LT minus 1, isn't it? Yes. Now, force, tension. What is force is what? Mass times acceleration, which is M LT minus what? 2, isn't it? Yes. So this is force. The other thing there is what? L. We've written this, which is this, which is this. Then L. What is the dimension of L? L. L is L, isn't it? What's the dimension of this last one? M. M is also what? M. Is that clear? Is that clear? Now from this, changing every of these to this, what do we have? In place of V, what would we write? We will write what? LT minus 1, isn't it? Yeah. Because this is similar to this in terms of dimension. Equal to K. F is the same thing as what? F is the same thing as M LT minus 2 to power what? A. L is the same thing as what? L. And M is the same thing as what? M. Huh? Yes. So this is what we have. This is the same thing as this equation up here. Isn't it? Yes. Now, we are going to equate the powers. Equating the powers of L, T, M on both sides. Equating the powers of what? L, T, M on both sides. Now, number 1, we pick out the powers of M. Number 2, we pick out the powers of what? L. And number 3, we pick out the powers of what? T. So let's equate the powers of M. What do we have? M here. Is there any M here? No. There's no M here, man. Yes. So what do we call it? If there is no M, what do we call it? Call it 0 equal to. Is there any M here? Yes. How many M? 1. Which is the power what? 2. Back? Yes. Then do you have another M? Is there any other m there?
No.
This is m to power a. This is another m to power what? C. Isn't it?
Yes.
Equating the powers of L. What do we have? Do we have any L here?
Yes.
So we have what? 1. Isn't it?
Yes.
Equal to what? Is there any L here?
Yes.
How many?
1.
A. Is there any other L?
Yes.
B. Isn't it?
Yes.
Good. So let's equate the powers of T. Let's equate the powers of T.
1.
So how many T here?
One.
Equal what?
1.
Minus what? 1. Equal to T. What do we have T here?
A.
A, man.
Yes.
Any other T?
No.
Any other T?
No.
But T here is minus 2A. Minus 2. T minus 2, isn't it?
Yes.
Minus 2A. So we have minus 2A. Yes, minus 1. Yes, minus 2. Is that clear?
Yes.
Is that clear?
Yes, sir.
Is that clear?
Yes.
So we can solve this equation now. This is equation. Let's say this is equation A, equation B, and equation what? C. We can solve these 3 equations simultaneously. If we solve this equation, 3 equations simultaneously, what will be the value of A? A now is equal to minus 1 over minus what? 2, which is presented as what? 1 over 2. Is it not?
Yes.
A is 1 over 2. What is B? If we have 1 here, for equation, if we have 1 is equal to A, we already know that A is 1 over what? 2 plus B. So what will be the value of B? B will be equal to 1 minus half. And 1 minus half is the same thing as what? Half. Isn't it?
Yes.
So B is also equal to 1 over what? 2. A is 1 over 2, B is 1 over 2. So what is C? Can you see it here?
Yes.
You can carry this C and come over. You can carry A and come here so that you can say that C is equal to minus what? A, which is the same thing as saying minus what? 1 over 2. So C is actually equal to what? Minus 1 over 2. So now you can see the values of the A, B, and C that we use in this so that we can replace it. Is that clear?
Yes, sir.
So we can now say that in essence V is equal to K F to power what?
1 over 2.
1 over 2. L to power what?
1 over 2.
1 over 2. M to power what?
1 over 2.
Minus 1 over 2. So this is the actual relationship. Is that clear?
Yes, sir.
That is the actual what? Relationship. So this is the same thing as saying F equal to FL all over what? M. Root. Where those roots, the roots represent the half
1 over
2. Is that clear?
Yes, sir.
So that's another way of solving it. So let me explain this. We assume from the relationship that we have that B is equal to what? K, F to power A, L to power and M to power C. But we don't know the actual values of the A. So to find out the actual values of these, first of all, we did what? We represented everything that we have here in terms of their dimensions. Velocity is the same thing as LT to power minus 1. Force or tension is the same thing as MLT to power minus 2. L is the same thing as L. M is the same thing as what? M. Is that clear? Yes. Now we'll rewrite this equation in terms of the what? Dimensions. Is that clear? Yes. Then now we equate the powers of L, T, M on both sides. So we start with M. What is the value of M, power of M on this side? 0. But what is the value of M, power of M on this side? We have M here to power what? A, which is here. M to power what? C. That's equation A, the first equation. Then for L, what is the power of L on this side?
1.
1. Isn't it?
Yes.
Equal to what is the power of L on this side?
A.
L to power A. So A. What is the value power here? B plus B. Then for the third one, T. What is the power of T here?
Minus 1.
Minus 1. What is the power of T here?
Minus 2.
Minus 2A. Is Is that clear?
Yes.
So we'll solve out this equation. If minus 1 is equal to minus 2a, a is the same thing as minus 1 over minus 2, which is half. If we take the value of a here, which is half, and put here, you see that b is the same thing as what?
1 half.
It's the same thing as half. Is that clear?
Yes.
B is the same thing as what?
Half.
Half. You understand?
Yes.
So if we do the same here, we will put the value of a here. A is already half. Put half here. To make c the subject, you carry this one and go over here. We have minus half, isn't it? So if you replace all those values, half, and minus half, here we have b equal to k to power what?
Half.
F half, l to power half, and m to power minus half. Is that clear?
Yes.
Because we have half all through, you can put it to be equal to what? Root fl what over what? M. But you see that these ones are having half. That's why they are inside the what? Square root. So we now put k here. So making this the final what? Formula. So with the knowledge of dimension, you're able to find out that the velocity of vibration of the flux string can be related to all these fundamental quantity using this very formula. Is that clear?
Yes.
Is that clear?
Yes.
So that's one aspect